Let's talk about a clustering scenario where the cluster centers are deliberately placed at the locations where not occupied by any data point, so which confirms that the principle that centers in clustering algorithms such as k-means algorithm need not to be actual data points, but are rather calculated based on the means of the points in the cluster, which may or may not coincide with the existing data points. This flexibility in placing centers anywhere allows the clustering algorithm to more effectively minimize the total distance between points and their respective centers, which may lead to more optimal clustering solution, especially in non-uniformly distributed datasets. This model helps us to clarify why k-means algorithms are more powerful tools in data analysis, which provide the flexibility needed to find the meaningful clusters in variety of datasets. So this helps us to demonstrate that cluster centers in k-means algorithm are computed as the mean of assigned points and may not correspond to any actual data point in the set. Let's try to illustrate the concept of ties in clustering, where a data point is equidistant to more cluster centers, and how such ties must be broken to ensure each point belongs to exactly one cluster. In this simulated scenario, where points are placed strategically to create potential ties, so these ties can be resolved and often arbitrarily to meet the requirement of unique cluster assignment per point. These centers are placed to form an equilateral triangle, which increases the likelihood of points being equidistant to multiple centers. So these points were placed to potentially tie between more centers, which based on the Euclidean distances, and we connect each point to arbitrarily chosen nearest center. So this choice was made by selecting the first center that came up by the minimum in the distance calculation, which demonstrating one way to break ties. In real-world applications and k-means algorithms, when a point is equidistant to more centers, ties are typically broken arbitrarily unless some additional rules are specified. So this may be based on the index order of centers or other criteria like cluster sizes. The way ties are broken can affect the final clustering results, especially in some datasets where many points lie near the boundaries between the clusters. This visualization helps us to understand that in clustering, each point might ultimately belong to exactly one cluster, even if it means resolving ties in arbitrary manners, but ensuring clear and decisive cluster assignments. Let's talk about the stability in cluster assignment when cluster centers are moved. So a point's cluster assignment is changed only if the distance to a new center is strictly smaller than the distance to its older center. So this rule ensures that points are not reassigned to the new clusters unless there is a clear benefit in terms of proximity. These points that remain connected to their initial centers demonstrate stability, whereas any reassignments are strictly due to a closer proximity to new center compared with the old one. So this model effectively shows how cluster assignments are maintained unless a significant reduction in distance to new center justifies a change, which is crucial in dynamic clustering environment where centers may shift slightly over time or iteration. So this can ensure minimal disruption and more consistent clustering results.